All right. Good evening, students. I hope you are able to hear me. If you are able to hear me, press yes. Yes, Samir. Right. So, good evening, Ganesh, Ravi Kumar, Basavraj, Pradeep, Pratesh, Adesh, Pranav, Meghna, Sameer, Kushi, Tejas, Chaitra, Sanjana, Siddharth. Good evening, guys. Ankit, good evening. Viresh, Chinmay Kulkarni, Siddharth, good evening. Abhishek, Athar, good evening. Pranav Shivkumar, Prashant Satyakal, Deepti, Vani, Varsha, good evening. Good evening, Advait. Good evening, Preksha. Yes. So this is not just to tell you that or kind of demotivate you from being an engineer, right? Being an engineer is definitely a good profession. In fact, in the coming 5 years, you'll see a big boom in the technical field, right? But the idea here is to tell you that you don't have big expectations, right? You don't have big expectations. You just go out there and do something real. Don't just buy hard books and become an engineer. If you buy hard books and become an engineer, it's not going to help you, right? So if you really want to be a good engineer, be more technical, be more practical, right? Gain more experiences through internships and all, right? That's something which is more important, right? That's something which is more important. It's not just like, okay, I want to pass this CGPA, I want to get this CGPA, I want to get a degree. Getting a degree is not engineering. So when you see people struggle with the engineering degree, that's because they just pass the engineering degree. They don't learn anything there. So be more technical, be more sound, be more innovative. You'll definitely do great things. Okay? So let's start our class. So I guess last class we had finished alcohols, right? And to be honest, it's not just with engineers, it's with every field, right? Be it doctor, be it anyone, right? No, I won't say being an engineer is a bad profession, right? As I told you, Vishal, coming 5 years, you'll see engineering as a very big boom, right? Technical things will be very, the see. If it was not engineers, we would not be talking to each other like this, right? So obviously, we can't say that engineering is a bad profession. It is because of engineers only we are talking to each other like this, virtually, without even seeing each other, right? So, like engineering will always be a good profession for those who become a good engineer. And if you just buy hard the books, it's not going to help you. It's true with every case. Okay? Adesh, Adesh, 10 p.m. Right? So let's start. I don't think so, Gokul. Nothing will see a fall, right? Everything has a time. So maybe something will have upper time, something will have a lower time. Nobody will see a fall. Okay? Good evening, Hina. Yes, very rightly said, Preksha. I forgot, Dhanush. I'll send you after the class. By tonight, I'll send you, Dhanush. I didn't get you, Siddharth. I didn't get you, Siddharth. What are you asking about? Siddharth, what are you asking about? I think so, yes. The meeting has some lock setting. So Zoom is doing some security setup. I don't know why. So maybe next 10 minutes. That's what. Chalo, let's start our class. So what we were discussing last class, I guess Last class we had, yeah, last class I guess we had finished phenols, right? I guess we had finished phenols. Phenols, all the properties we had finished. We had started with ethers. We had done the IUPAC name of ethers, how to name ethers, right? We had discussed about test for phenols, neutral efficiency test, Lieberman nitrosa test, steric ammonium nitrate test, physical property uses of phenol, and then we had also discussed iodoform test, right? And there was one homework also. Have you guys done this? That's a good question, Chandana. Obviously, I can't tell you this here. Message me, Chandana. I'll talk to you separately. So, yeah. Have you guys tried this question? If you have tried this question, then definitely let me give you the options and tell you what answers you are getting. Yes, it's a question of phenol, right? So you can try this one and tell me what answer you are getting. What answers you guys get on this? That I don't know, Samir. We have to figure it out. We are also new to this, right? Are you sure, Preksha? Chalo, we'll see soon. C7H8 won't exist. Who is this? Pranav, why it can't exist? It can exist. Then Preksha, maybe you have got this question in some of the book. Maybe you have got this question in some of the book. Array, it is not AT, man. It is oxygen, C7H8O. Array, Pranav. Chalo, let's see the answer. So I'll end this. If you have got the answer, please vote fast. If you have got the answer, please vote fast. Obviously, Janvi and Aditi's answer I have got. Oh, got it, Preksha. So let's end it on account of 3 then. So if you have got the answer, please vote. So we are ending it on account of 3, 2, 1. Let's end this now. See, there are a lot of spectators today who have not voted at all. So I see a lot of spectators who have not voted at all. That's good. Keep doing it. That definitely fetch big success. Not participating, not answering gives a big success in life. Seriously, keep doing it. So C7H8O is my compound, right? So obviously you should understand first that out of this C6H5 will be benzene, right? So if I take benzene, it is 6,6H6, right? If I take OH on it, right, then it is C6H5, C6H5O and H. You can write it as C6H6O. Then you have 1 carbon extra and 3 hydrogen extra. That means there should be 1 CH3, correct? So there is one, this is a benzene with OH and CH3 group, obviously, right? Benzene with OH and CH3 group. Now it can be ortho, meta or para. Let us see the answer. Sodium bicarbonate, it is insoluble in water and dilute sodium bicarbonate but dissolves in aqueous NaOH, right? So we know, see, bicarbonate is a weak base. So only strong acid can dissolve in it. Phenols are weak acid, correct? So definitely A is wrong. Why A is wrong? It dissolves in strong base. It dissolves in strong base. That means your compound should be slightly acidic. Alcohols are very weaker acid than phenol, right? So we cannot take alcohol. Phenol should be our compound. Because it is soluble in base, compound should be acidic. Okay? Now, it gives a characteristic color of FeCl3. So FeCl3 test is also given by phenol, not by alcohol. This is aliphatic alcohol. So again, it cannot be the correct answer, right? So this is not phenol. So phenol can only give FeCl3 test. We had discussed it last class, right? FeCl3 test is given only by phenol, right? Then on treatment with bromine water, it gives a precipitate of tribromo product, right? So if I take, I know this, if I take a phenol and treat it with bromine water, I get bromine at, this is 1, 2, 3, 4, 5, 6, ortho and para. So I'll get it at 2, 6 and 4 position. I'll get Br. So I am getting 2, 4, 6 pe Br. That means your methyl should not be present at 2, 4, 6, right? That means ortho and para should be free. If ortho and para is free, then only you can get 3 Br. So in this, ortho is blocked. So if you add bromine water, one bromine will come here, one bromine will come here. You should get Br2, but we have Br3, so this is wrong. Here, para is blocked. Here, para is blocked. So if you do bromination, one ortho here, one ortho here. So again, you should get Br2, but we have Br3. This is wrong. This is correct. Because here, both the ortho and para is free to give you tribromo product, right? So you can get a tribromo product only with option D. So your correct answer here is option D, not option B. So I can show you the results. Most of you have voted in the favor of D. I hope it is clear. The crucial reaction here was this reaction, right? So the correct answer here is D. Is that clear, everyone? Is that clear? But OH wants to send CSC. Wow, Pranav, you are legend. Pranav, we are already saying methyl is not coming. Methyl is already present. This is our reactant product. We are not forming this in reaction. We are talking about this compound is already present. So why are you sending the methyl at orthopara? This compound is already present. Yes. Any doubt whatsoever, anyone? So this reaction was a crucial part in this question. Without this, you can't solve it. So the correct answer here is D. Anybody having any doubt, please ask. We'll move ahead. Anybody having any doubt, please ask. We'll move ahead. Very good. Right. So let's move ahead. I am personally thinking of nominating you guys for Oscar this year. This year, particularly. In this pandemic year, you guys deserve an Oscar. Guess why? Chalo, let's take our recall test. Yeah, this is a good one. This is really a good one. Please, it has used all the reactions in this chapter. It has used all the reaction in this chapter, right? So why you should get a Nobel Prize? No, not Nobel Prize, sorry, Oscar Award. Why you should get that? You know? Because you need a terrible patience. You need a terrible patience that a person who is shouting in front of you and you still are looking like this. Right? So you are so unresponsive. To be that much unresponsive, you need a terrible patience. So you should get it for showing the uncomparable or unrealistic patience in life. You should get it. Right. So this is your answer, guys. Sorry, question, guys. Please check this carefully. So it has used all the reactions of the chapter. Yeah, Rohan, correct. Yes, Vijay. Correct. Yes, this is a very good question. It has used all the distinguished tests here. So let me see how many of you have voted. Very few, as usual. So not a problem. I'll give you another 30 seconds for this. I'll give you another 30 seconds for this. Right. So let me end this on a count of 3. Let me end this on a count of 3, 2, 1. So let's end them now. Right. So most, you can see the results. Most of you have voted for B. Some of you have voted for C, A, and D also. Right. So let's see this. So first thing is, it is giving these tests. Chromic acid. So I'll come to this later. Lucas reagent. Which alcohol do not give Lucas test? Which alcohol do not give Lucas test? Yes, Chetan, you're doing terrible mistake. Primary alcohol do not give Lucas test because primary carbotan is not stable. This is not giving any Lucas test. That means your alcohol is primary. Your alcohol is primary. Okay? It should be a primary alcohol. Okay? If it is an alcohol, it gives bubbles with sodium metal. It gives bubbles with sodium metal. So ketones do not react with sodium metal. Aldehyde do not react with sodium metal. So this is your ether actually, ROR. So only alcohols can react with sodium metal. So obviously the answer is B. Then decolorized bromine water. That means there should be some unsaturation or it should be phenol. These two compounds can only react with bromine water. So there is a unsaturation, double bond here. So only this compound can give you test for unsaturation, right? So chromic acid means what? This is your chromic acid, HCrO4. I told you all chromium compounds are strong oxidizing agent, and chromium compounds are orange color. So they will oxidize your primary alcohol directly to acid, carboxylic acid, and they will themselves get reduced to CrC+, which is green. So your correct answer here is B, right? The correct answer here is B. Is that clear, everyone? So you need to see the options and the hints given to you in the question very carefully. If you miss out on one single hint, then you're gone. Right? So yeah, any doubt in this? Anyone? Any or many one? Any or many doubt on this? Please ask. If anyone or many one has any doubt on this, please ask. Doubt तो तुम लोग के नहीं आते हैं. You guys don't get doubt generally, but you score terribly good in exams. You score terribly well in exams. That's also a talent, you know. That's also a talent which very rarely people can have. So maybe Nobel Prize for that. I'll try to recommend for that Nobel Prize. Right? Chalo. Let's move ahead. I saw that, Athar. So let's move ahead. So we will start with the preparation of ethers. We have already done the IUPAC nomenclature. So we'll start with preparation of ethers, right? So when I start with preparation of ethers, there are hardly 3 preparations we have to study. First of them, which is the most important, and you have to remember this only mainly, is your Williamson synthesis. This will come in your board also for 2 marks if it is coming as a definition. If it is coming only as a reaction, for 1 mark. Right. Williamson synthesis. Right? Kane Williamson, New Zealand capital. So Williamson synthesis, have we studied this before? Have we studied this before? Yes, have we studied this or we are seeing this first time? We have studied this in examples of nucleophilic substitution reaction in which reaction? In SN2 के examples में. So nucleophilic substitution reaction in alkyl halides and aryl halides, we have studied this. Okay? So now let us see what is the reaction. I'll tell you. You will take a alkyl halide. You will take a alkyl halide and you will treat it with RONA. Right? You will treat it with RONA. So if you take RONA, what is it going to do? It will give you RO minus. Now RO minus can act as a good base also, right? It can act as a good base also. It can even act as a good nucleophile also, right? Now can you tell me when it will act as a good base and when it will act as a good nucleophile? Yes. Can you tell me when it will RO minus, when it will act as a good base and when it will act as a good nucleophile? Yes. Very good. So it depends upon 2-3 factors, right? If your R is bulky, if this is bulky, then it will act as a good base. Or if this R is bulky, tertiary alkyl halide, then also it will act as a base and do elimination reaction, right? Otherwise, if neither this is bulky nor this is bulky, it can act as a nucleophile. Okay? So in the presence of ROH as the solvent, let us take R dash here. So what will happen? X can be chlorine, bromine, iodine, halogens. So we know halogens are good leaving group. It will leave like this. X will get a negative charge. R will get a positive charge. So RO minus will attack carbon having positive charge. So that you'll get ROR dash. That is ether. Right? That is ether. For example, if you take CH3Cl treated with CH3CH2O minus Na plus in the presence of CH3CH2OH as the solvent. So CH3CH2O minus will act as a nucleophile and substitute Cl. So you'll get CH3CH2O minus has attacked CH3. You'll get this ether, right? And the name of this is very easy. Smaller alkyl group as alkoxy. So it will be named as methoxy. Methoxy. 2-carbon alkane is ethane. Or common name is ethyl methyl ether, right? So is the reaction clear to everyone? Is the reaction clear to everyone? Is the reaction clear to everyone? Right. So this is a basic reaction. Now there are some limitations here. What are those limitations? Let us say I want to prepare, let us take the limitations. Limitations for special cases, whatever you want to give it a name, you can give it. If I want to prepare this ether, yes, this is my ether I want to prepare. Now, can you tell me what should be my RONA and what should be my RX? What should be my RONA and what should be my RX? There are two possibilities. If I take CH3X, right? And if I take CH3, O minus, N plus, right? Then X will leave, CH3O minus will attack, and you'll get this product. This is one path. What is the other possibility? You take CH3, Cl, and here you take, let us say, CH3ONA. This will also, Cl will leave, O minus will attack. So this will give you also the same product by path B. Which of these two is the right method for preparing this ether? Path 1 or path 2? With reason. Which path you will choose to prepare this ether? Path 1 or path 2? With reason, guys, with reason. Don't answer without reason. All right. How to type long reason? Chota likh do kuch. Right. So now see here, the correct method is first one. Correct method is first one. Right? Because when you take tertiary halide, we want to do SN2 reaction. We want to do nucleophile substitution reaction. When you take a tertiary halide, it will promote what? Elimination. It will promote what? Elimination. But here, you cannot do elimination with only one carbon. For doing elimination, from one carbon halogen goes, from other carbon hydrogen goes. But you have only one carbon here, so elimination is not possible. Right? So you will get substitution product only. Right? Since you are using a tertiary alkyl halide gives elimination rather than substitution. Therefore, with tertiary alkyl halide, you will get more elimination product, which will be this. Whereas with primary halide, you get more substitution product. Therefore, the correct answer is path 1, not path 2. Is that clear, everyone? Is that clear, everyone? Path 1 is the correct method because in path 2, you will get elimination product also. Tertiary alkyl halide gives elimination reaction. I hope it is clear. This is one case, one such case. We can also say attack is not easy in seconds. You can say that, up to you, how you consider. It is sterically hindered, so SN2 is not possible in this. You can say that. SN2 depends upon steric hindrance. And why SN2, not SN1? Because our nucleophile R- is a strong nucleophile. Is that clear? Any doubt? Anyone whatsoever in case 1? Anyone having any doubt in case 1, please ask. I'm going to move ahead in next 5 seconds. Very good. Now let us take the next case. If you want to prepare phenyl ether, let's say you want to prepare this ether. We cannot do SN1 Mohit because your nucleophile is strong. Strong nucleophile will not favor SN1. Okay? Reason beta Basan Goda, if you would have asked little earlier, I would not have moved to the next slide. Correct? Now I have to come back. That's why I asked little earlier. So the reason is quite simple. If you have studied elimination, which I taught you for E1 or E2, if you take tertiary alkyl halide, probability of elimination is more than secondary than primary. Since you have taken tertiary alkyl halide, rather than giving you substitution, this is substitution product. Rather than giving you substitution, it will give you elimination because tertiary alkyl halide is hindered. It promotes elimination more than substitution. So Cl goes like this. Carbon gets positive charge. From next carbon, H plus will be eliminated. Carbon negative, positive double bond. You'll get elimination product in tertiary alkyl halide. Primary alkyl halide elimination is not possible. You'll get only substitution product. Is that clear, Vasan Goda? Yes, Vasan Goda. Is it clear? Or you can also say the substitution here is SN2, and SN2 is very slow in tertiary, so tertiary will not give SN2. You can say that also. Carbocation, why will you fall, man? It is strong nucleophile, na? In strong nucleophile, you cannot give SN1 mechanism. Okay? Right. So now this is your ether. How would you prepare this ether? What should be your reagents? To prepare this ether, what should be your reagents? To prepare these reagents, sorry, this product, what should be your reagent? Don't type their names. Sulfuric acid. Where are you seeing sulfuric acid in Williamson synthesis, beta Kishore? Where are you seeing sulfuric acid? We have taken alkyl halide, we have taken RX and RONA. I am asking what will be your RX, what will be your RONA. For this, I had chosen these two as my reagent. Where is H2SO4 here? So let us see. The two, again, I will give you the options. One possibility is if you take halogen on benzene and you take CH3O minus Na plus. So again, X will leave and this will attack. This is path 1. The other possibility is if you take O minus Na plus RONA of benzene and take CH3Cl. So O minus attack carbon having positive charge. This is your path 2. Now again tell me which is the correct path. Path 1 or path 2? Which is the correct path? Path 1 or path 2? Okay. Very versatile answers. Very good, Netra. Very good, Priyadarshini. Chalo. So let me end this. Very good, Adesh. Very good, Basavraj. Very good, Pratibha. Ganesh, correct. So let me. Aum Kulkarni is also right. Pritesh obviously right. So path 2 is correct. Why path 2 is correct? You guys, I guess, forgot we are doing substitution reaction, and I had told you aryl halides do not give nucleophilic substitution reaction because of resonance. Because of resonance, they get what? Partial double bond character. So since you get due to resonance, you get double bond here. It is difficult to break and remove halogen and substitute it with OCH3. It's not possible to substitute X with OCH3 because due to resonance, there is a double bond here and double bond is difficult to break, right? So if you want to prepare any aryl ether, always take RONA of benzene. Always take RONA of benzene. Is that clear, everyone? Yes. Is that clear, everyone? Is it clear to everyone? Yes, Adesh. Now let's move ahead. Let us take one more case. This was one of the previous year KVPI questions. Let us say I want to prepare this ether. What should be my reagent? Again, I'll be giving you two products, two options, path 1 and path 2. X, CH3ONA. This is path 1. Then the other possibility is this is your path 2. Which path is the preferred path here? Which path is the preferred path here? Path 1 or path 2? Be careful while answering. Do not answer in a hurry. pass 1 or pass 2 with a reason. Do not just jump and tell your answer. Got it. Chalo, let us end this. Let us end this and see what answer. The correct answer is path 2. Why path 2? I guess you didn't get this substituent. You should have understood this substituent carefully. If you see this substituent, it is nothing but draw it as a 6-membered ring. Then these two are connected by CH2, 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 right? 3 CH2. So draw CH2, CH2, and CH2. And here you have halogen. Correct? Yes? Now, if you remember, I told you this is called bridgehead position. And I told you bridgehead position, say neither SN1 take place nor SN2 take place. So substitution not possible with this. Substitution not possible with this. Substitution not possible with this. Is that clear? We have done it many times in first year also, we have done it in second year also. So the only thing is when they write it like this, it's difficult to catch it that it's a bridgehead carbo, bridgehead position. In bridgehead position, neither you'll get SN1 nor you'll get SN2, right? So all these 3 special cases, remember it, limitation special cases of Williamson synthesis, whatever you say is up to you, right? Are Preshta, this we have already done. No, Preshta, do you remember we had done this bridgehead position? Here you cannot get carbocation here because carbocation is sp2 and this cannot become planar, because if it has to become planar, this should become like this. So this should go up, this should also go up. When you try to pull these 2 bonds up, these 2 bonds will move away and ring will break. So since this carbon cannot become planar and sp2 dies, therefore carbocation here is not stable. So SN1 is not possible. Now if you talk about SN2, from the back side, nucleophile should come in SN2. So back side is protected by these 3 carbons. So where will nucleophile attack this carbon from? So due to lot of steric hindrance, it cannot give SN2 also. So substitution is not possible only. Substitution is not possible only. So therefore we cannot choose this option. We have to choose halogen on CH3. Is that clear, Preksha? This was the limitation of SN. This was the exception in SN1 and SN2. If you see that, okay. So let's move ahead and discuss some more preparation. Now the remaining preparations are very easy. Only 2 methods I'll see. One is from alcohols. From alcohols. If I take alcohol, 2 molecules, and treat it with concentrated H2SO4 at a temperature of 100 to 120 degrees Celsius, you will get ROR ether plus water, right? You'll get ether as the product. Remember this, when you treat alcohol with concentrated sulfuric acid, what do you get? Yes. I have taught you this before also. Do you remember if you treat alcohol with concentrated sulfuric acid, what do you get? This is which reaction? Which reaction is this? Yes, it is very good, Pratish. It is called dehydration reaction, and dehydration of alcohol gives you alkene, correct? But I told you this reaction is temperature dependent. If you take high temperature, then only dehydration will take place. The temperature we mentioned there was 160 to 180 degrees Celsius. So at a high temperature of 160 to 180 degrees Celsius, elimination takes place and you get alkene. But here I am taking lower temperature. So at lower temperature, elimination will not take place, substitution will take place, and you will get ether, right? So let us take this. So what I'll do is I'll take an example of RCH2CH2OH, right? So if you take concentrated sulfuric acid, so the first step is same. It will give H plus ion. So OH will get protonated first, so that you get RCH2, CH2, OH2 plus. It will lose a molecule of water and you will get a carbocation. So till here, no change. Till here, no change. Correct? So it's a primary carbocation. You can rearrange it into secondary. It's up to your wish. How do you do it? You can rearrange it to secondary carbocation, RCH plus CH3. Now from here, if you take the temperature as 160 to 180 degrees Celsius, then from the next carbon, hydrogen will be eliminated and you'll get an alkene. We have already done this. But if you take a temperature of 100 to 120 degrees Celsius, lower temperature phase substitution will take place. Take another molecule of alcohol, RCH2CH2, OH, lone pair. This will attack the carbocation so that you'll get RCH, oxygen has donated lone pair, CH2, CH2R. Positive charge. Now it will lose H plus to remove the positive charge and you'll get RCH, CH3, O, CH2, CH2R. Right? So basically, at a lower temperature, you have done nucleophilic substitution. At a higher temperature, you have done the elimination to get alkene. Is that clear, everyone? Is that clear, everyone? This is also one of the method of preparation of ether. See now, this is ether. R-O-R, ether. Yes? Correct. Any doubts? Please post again quickly. Again, this is not important for your boards. Only Williamson synthesis is important for your boards. Fourth step. This is first, second, third, fourth. Are you asking this step, Abhishek? Are you asking this step, Abhishek? Beta, nothing, no. This is carbocation. Carbocation is sp2 hybridized. It has empty p orbital. So this is electron rich. It will donate lone pair to carbon. It has empty p orbital. So it will donate lone pair to carbon like a coordinate bond. If it donates lone pair, it will have a positive charge, oxygen, because oxygen has donated lone pair. So carbon-oxygen bond is formed. Since it has positive charge, it will break this OH bond like this to get negative, negative positive neutral. H plus will be removed. So H plus is removed. Is that clear? I have already explained the substitution reaction, Priyadarshini. Is it clear to you? I have seen that Vivekanand. Priyadarshini, is it clear? Very good. If the temperature is 140 degrees Celsius, then elimination will take place. Then elimination will take place after. Okay? We'll move ahead. Chalo, let's move to the third and last preparation. Third and the last preparation is, so if you take the third and the last preparation, it is from oxymercuration, demercuration. So can you tell me, oxymercuration, demercuration is a Markovnikov addition or anti-Markovnikov addition? Oxymercuration, demercuration is a Markovnikov addition or anti-Markovnikov addition? Gauri, oxymercuration, demercuration is a Markovnikov or anti-Markovnikov? What's wrong with you, Ankita? It's a Markovnikov addition. It's a Markovnikov and trans addition. Correct? Markovnikov and trans addition. So what do you add? What do you add in Markovnikov addition? Addition of what? What do you add? You add haldi, turmeric, cinnamon. What do you add? We add water. We add not halogen base. We add water. So we add HOH. We add HOH and the reagent we take is NaBH4. So Markovnikov addition means the carbon having more number of hydrogen will get hydrogen. So this carbon will get hydrogen because it has 2 hydrogens, and this carbon has less hydrogen, so it will take OH. So if you do the Markovnikov addition, you will get RCH2, you will get H here and OH here. Right? This is what we do. No carbocation formation. This is what we do. Yeah, we take HgOAc whole twice also. I have to take here HgOAc whole twice. Mercury acetate, and here NaBH4, and addition of water takes place. This is the product you will get. Then how do we get ether? Nothing. Instead of water, you take R here. That means you take instead of water alcohol. So rather than adding H and OH, you add H and OR. That's all. You add H and OR. You add H and OR. You got your ether. This is your ROR, ether. Just instead of OH, you add OR. Matlab, instead of water, you add alcohol. In oxymercuration, demercuration, you'll get ether. Is that clear, everyone? This is how you should remember it also. If I add water, I will get alcohol. If I add alcohol, I'll get ether. Is that clear, everyone? Please see this carefully. We'll take some questions on this. Yes? Got it, Preksha. Is that clear, everyone? Where the Preksha, we have done 3 reactions today. 3. So let's move ahead. So let's do a question on this. So you see, there are 4 alkyl halides given to you. You have to rate them in their decreasing order of reactivity. You have to rate them in their decreasing order of reactivity. Which alkyl halide will react fastest in Williamson synthesis and which will react slowest in Williamson synthesis. So rate them in their decreasing order of reactivity. Yes. This is a good question. Right. So this is a very good question. To answer, 2 reactions. 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 2 to options you can easily rule out. You can easily rule out two options. Yes. So let Samriti, I got your answer. So you have another 10 seconds to vote this. I will end it in 10 seconds. Two options are easily ruled out. There is no doubt about it. Yes. So let's end it on a count of 3, 2, 1. Let's see the answer now. Right. So here, first thing I see here is this is having lot of steric hindrance, bulky. It is having lot of steric hindrance. So since Williamson synthesis is SN2, so steric hindrance is more, so its reactivity will be least. So A should be least. A least in these three options. So B is definitely wrong. That means B is definitely wrong, right? Then among C and D, number of carbons are same, CH3, CH2, CH2, CH3, CH2, CH2. So here you have CCl bond, here you have CBr bond. Which bond will break more, or SN2 which is more reactive, bromide or chloride? Which is more reactive, bromide or chloride? Bromide, because Br is a good leaving group, or the bond is longer, it will break easily. So D should be more than C. Then here C is more than D, so definitely D option is also wrong. D should be more than C, because bromides are more reactive than chlorides. Is that clear, everyone? Yes, everyone. Is that clear? Now, coming to these two options, now we are left with whether this will be more reactive or less reactive. Whether this will be more reactive or less reactive. It will be more reactive. I told you allylic halides with strong nucleophile give SN2 easily. Allylic halides with strong nucleophile give SN2 easily. That is one of the reasons. Or you can even say these are planar atoms, right? Number of hydrogen atoms are less. So here steric hindrance will be more because the hydrogen atoms are more, right? So in every aspect, B should be more reactive. So you can say A is the correct option because B should be most reactive. So this double bond will basically, one, reduce the steric hindrance. Second, allylic halides and benzylic halides can give SN2 with strong nucleophile. Strong nucleophile के साथ they can give SN2, right? So the correct answer here should be A. ठीक है? Correct answer here should be A. वैसे I'll still verify from the source. This is what I feel. A should be correct. ठीक है? चलो, let's move ahead with the one more question we'll do. Look at this one. This one is interesting. Look at this one. This is also Williamson synthesis. So look at this one. Look at this one. Preksha, was that clear to you? Yes, Preksha, was that clear to you? P for Preksha, W for was, C for clear. Good. So yeah, you can check this question. See, now the questions in organic are always interdisciplinary. That means you will not get it from one chapter, you will get it from most of the chapters. Right? You will get it from most of the chapters. So here you have first chapter ka reaction, haloalkanes, haloarenes ka. First you have to draw X, then you have to draw M. This is relatively an easier one, so I think it should not be a problem. This is relatively an easier one, so it should not be a problem. In fact, all the options are useless. This is a directly easy question. Yes. You will get slow people, you will only get 30 more seconds to vote. You people are voting like sloth. Very slow. So you people are really voting like sloths. All right. So you have last 10 seconds. Yes. So here I am going to end this on a count of 3, 2, 1. Let's see the answer now. That's very easy question, to be honest. Yes. So what is the role of NBS? What is the role of NBS? Tell me that first. Presha, you need to tell me what is the role of NBS? N-bromosuccinamide. What does it do? It does. Very good, Pritesh. Very good, Ruchi. It does allylic halogenation. It does allylic halogenation. So double bond, next position is allylic. So here bromination will take place. So you'll get your X product as this. Br, and here also Br. Allylic bromination has taken place. Now CH3 CH2O minus will act as a nucleophile to do Williamson synthesis. So it will replace CH2Br or this Br. Where it will attack? First or second? Where it will attack? First or second? Where it will attack? First or second? We have already discussed this. If you still do it wrong, then you are really legend. This cannot take place. This cannot take place because aryl halides have partial double bond character. So it is difficult to substitute Br. I had already told you this. Here, we cannot use aryl halides, right? So therefore, no substitution will take place at this bromine. Only substitution will take place here. So your product obtained will be this. CH2 Br has gone out, O CH2 CH3 has come in, and here you will get Br as it is. This will not get substituted. So correct answer is B, not C. C is wrong. Br will not get substituted. It is aryl halide. Aryl halide do not give Williamson synthesis. If it was something like this, orthonitro or paranitro, then it can give by SN-AR mechanism. If there is electron withdrawing group. If there is no electron withdrawing group, then nucleophilic substitution reaction is not possible with aryl halide. Right? Is that clear, everyone? Is that clear, everyone? So we have already done aryl halides do not give nucleophilic substitution reaction. Right? So let's move ahead. This you will take it as a homework. This is a previous year JEE Mains question. I think most likely 2019 question, some set. Try to solve this. We'll discuss its solution tomorrow. Right? Only at allylic position, Narek. Only at allylic position where bromine will be added. Why not C? I had already told no. I have finished Pura Ramayan and that said you cannot substitute Br with the nucleophile. You cannot substitute Br with the nucleophile because aryl halides do not give nucleophilic substitution reaction. Why? Due to resonance you get a double bond character. So this Br cannot be substituted with nucleophile. So therefore you will have Br as it is. Why will you get C? It will not give substitution reaction. Right? My God, sir. After explaining this only you are asking. I explained 2 or 3 times this thing. So keep your senses open. So this is your homework. Let's move ahead to physical properties. Physical properties. We'll start a new chapter tomorrow or day after tomorrow. We are almost done with this chapter. Only 2 reactions of ethers are left, right? So we will discuss, we'll do some problem solving tomorrow, and day after tomorrow we'll start the chapter, aldehyde ketone. Okay? Right. So if you talk about physical properties, if you take CH3OCH3 dimethyl ether and CH3CH2O CH2CH3 diethyl ether are gas and others are liquid. Other ethers are liquid, right? Second, if you talk about boiling point, alcohols have more boiling point than ethers, obviously. Why? Because alcohols have hydrogen bonding, intermolecular hydrogen bonding, whereas ethers, oxygen is more electronegative than carbon, so delta minus delta plus. So between 2 molecules of ether, you will have dipole-dipole interaction. Between 2 dipoles, you have a dipole-dipole interaction. And which is stronger? Hydrogen bonding is stronger than dipole-dipole interaction. Since hydrogen bonding is stronger than dipole-dipole interaction, therefore, alcohol will have higher boiling point. Right? This is what it means. Now, if you know this, let's move to the third one, which is, if you talk about dipole moment or polarity, if you compare. So dipole moment of ethers is less than alcohols. Just a minute. Right. So, yeah, last slide. Yes, done, Varsha? Right. So if you talk about these two, dipole moment of alcohol is more than ethers, right? What reason can you think about it? See, oxygen is more electronegative than carbon, so this dipole will be towards oxygen. This will also be towards oxygen. Right? Here also, oxygen is more electronegative than carbon, so dipole will be towards oxygen. Oxygen hydrogen mein, oxygen is more electronegative, again dipole is towards oxygen. Lone pair movement above. So they have similar structures, everything same. But still we are saying alcohol have more dipole moment than ether. Why? Because OH bond is more polar than OC bond. Right? So OH bond is more polar. Why? Because carbon has more electronegative than hydrogen. So here electronegative difference is 3.0 and 2.5. Here it is 3.0 and 2.1. So since the electronegative difference is more, OH bond is more polar. Therefore, its dipole moment is more. Right? So ethers are less polar. Since ethers are less polar, ethers are less soluble in water. Or insoluble in water because they cannot form hydrogen bond with water. Because they are less polar first, they are not much polar, and water is a polar solvent like dissolved life. They are less polar, and because they are less polar and cannot form hydrogen bond with water. Right? So electronegativity of O is 3.5. Sorry, carbon is 2.5, oxygen is 3.5, hydrogen is 2.1. Okay. So I hope we have taken the screenshot everything, right? So we will start with chemical properties tomorrow. We have to do only 2 or 3 reactions hardly. So we'll end this chapter and do more of problem solving on the whole chapter, right? And we'll see whether we'll start the next chapter tomorrow or we'll start the next chapter on Tuesday, sorry. Okay? Sorry, Wednesday. So we'll start a new chapter either most likely on Wednesday only. Okay, we'll do more of problem solving tomorrow. Okay? So that's all. If you have any doubts, you can ask. If you have any doubts, you can ask. Syllabus, I think November end May it will finish. November end or mid of November. Right. So let's do a Kahoot. Let's do a Kahoot. You can log into Kahoot.it. You can log into Kahoot.it. Oh yeah, tomorrow is a holiday. I forgot. You assume this chapter is finished, guys. There are hardly 2 reactions. I will most likely take some extra class somewhere and finish this. You assume this chapter is over. Yes, Anush. Yeah, tomorrow and day after tomorrow is a holiday, I know. For your batch. So your game pin is 8394226. 8394226. 8394226. 8394226 is your game pin. Yes. Right. Maybe Pratham, nothing is finalized yet. Why tomorrow is a holiday? It will be informed on your WhatsApp group. Justin, it will be informed to you guys. Game pin is 8394226. Pratibha, 8394226. 8394226. So we'll start. Got it. I'm waiting for some of you. How many of you? Yeah, I have seen that, Naren. If your board syllabus is to be considered, then we have already finished our syllabus. According to the recent PU board syllabus, we have to do only 2 chapters more. We have to do only 2 chapters more. Yes, I saw that. It was fixed match, Pranav. By the way, if you guys don't know, the guy who hit 5 sixes yesterday, Rahul Tevatia, I have played with him. He's from Faridabad, you can check it out. He used to stay near my school. Right. So I have played cricket with him. He is elder brother of one of my friends. I feel match was fixed, man. There was no Yorker in the last 3 overs. So terrible bowling. Chalo, let's end this. I just played, I was junior to him. So I played like friendly matches. Sometimes in his team only. How can I say? I feel because there was no Yorker in the last 3 overs. That's why. Which is surprising. Not poor captaincy. Captaincy was fine. Bowlers bowled bad. Chalo, let's start. So it's on hockey. It's on hockey, Indian pride in sports, hockey. It has won a lot of Olympic medals, right? Since long, we have won a lot of Olympic medals on it. So total number of players playing on the pitch in a hockey match is, total number of players playing on the pitch in a hockey match is, how many players play hockey in a hockey pitch? Very easy question to start with. Just giving you an easy start. First few questions are very easy. Yes, here we go. I was expecting this as the answer. The question was not how many players play in a team in a hockey match. Question was on a hockey pitch, how many players play together on a hockey pitch? 11 on both sides. 11 on both sides, so it is 22. Right? It is not 11. So I was knowing this. Pranav, you should use brain. Chalo, let's move ahead. And not only the clever question, I have kept the option 1 as 11 intentionally, so that people will not move to the next option B. Right? Chalo, let's see this. Check my game is on top. You don't believe your juniors, only 3 students answered it correctly. Atharv is back on 4th, Samriddhi on 2nd, Chirag on 3rd, Anirudh on 5th. Next one is an easy one due to history. Who is regarded as best Indian player in history of hockey? Best Indian player in history of hockey. Regarded as the best Indian player in history of hockey. So the answer we have here is, I think all of you will get it right. It's Major Dhyan. We have a Dhyan Chand trophy also in his name, right? So during the World War period, Hitler had offered him, we had defeated Germany, I guess, 11 something, 11-1 or 11-3 something. So Hitler offered him to join his army, he refused, right? So that famous story is there about Dhyan Chand. He was a magical player. So we have Check My Game on top, Chirag on 2nd, Anirudh on 3rd, Vinay on 4th, and Chinmay Kulkarni is on 5th. Third one. In which year did India participated in Olympics? In which year did India participated in Olympics? If you would have watched that movie of Akshay Kumar, Gold, it was related to this only. If you would have watched that movie of Akshay Kumar, Gold, it was related to this only. Yes, and the answer is obviously 1927. Some of you might have Googled also. The 1927 we started our Olympic campaign, right? And we won a lot of medals after that. The next one. So we have, this is surprising. Aditi shootingly gone to top. Parinita on 5th. These are lateral entries. Pritish is on 4th. Ashrit is on 2nd. Only Check My Game is remaining in top 5. This was surprising. Good one. Second last question. Which country has won maximum World Cup in hockey? Which country has won maximum World Cup in hockey? What would you say? Which country has won maximum World Cup in hockey? This is interesting. That's quite interesting one. Yes, I was knowing many of you will choose India, but unfortunately it's a wrong answer. Being patriotic and being logical is a different thing. Pakistan has won most of the World Cup in hockey. 1970s to 1995, I guess say. Pakistan was dominating the hockey like anything. So they have won 4 World Cups, right? And there are 2 more teams who have won 3 each, I guess Germany and Netherlands. Germany and Australia most likely. India and 1 more country, most likely Belgium, has won 1 World Cup each. So unfortunately you guys are wrong. So this will again change the tally list. Again, surprisingly, Aditi is still on the top. Janvi has come on third, Trisha on fourth, Athar is back on top 5, Ashit is still there in top 5. Last question, guys. Aditi, last bit for you. Yes, I hope Aditi and Janvi, you are not texting each other on WhatsApp and discussing answers. So the word hockey originated from a word hocket. So hocket, which means shepherd's crook. To which country this word belongs? So hocket is a word from which hockey is derived. To which country this word comes from? Or which language, whatever. Yes, I was knowing, still many of you have answered it correctly. It was French word. Hocket is a French word. Let's see the podium. On third, we have Trisha. From fourth to third, Trisha. Athar is back on top. Second, Aditi, I guess, is on top. Unfortunately, Aditi has won this time. Ashit and Pritesh is in top 5. Well played, guys. Very well played. Janvi lost on the last question, I guess. So that's all. So updates will be posted on your WhatsApp group. Don't miss it. We'll inform all the updates on your WhatsApp group. Okay? Right. So that's all for today. Your sis is always winning. Preksha, your sis is always winning. ठीक है Pritesh. I played him in academies. Chandan, we used to play in the same academy for some years, you would say. 1.5 years. Yes, correct, Adesh. Lot of messages. Yes, Chandana, I am messaging you. You should be having it actually. I am quite old for you now. I am good, Rohan. How's you? Yes, that's what I am saying, Justin. It was kind of a fixed match for me. You don't see a single Yorker or bouncer in the last 3 overs. That was very surprising. Physical property slide. Just a minute. I will cheer MI today, MI. This is physical property slide. No. When I used to play with him, he was a very good leg spinner. Like probably around best leg spinner around. He was a very good leg spinner from the beginning. Right? He was not that great batsman at that time. He started slog hitting maybe later, I would say. At that time, he used to bat 7th, I guess. Sometimes 6. Depends on the match. He was okay batsman. And like yesterday also, bowling was very bad, man. It was very bad bowling. So you can't just say, he played very awesome. Homework question slide. This is your homework question. Bye, Adesh. Second point. I hope you have taken it, Ankita. There is a big story about it, Rohan. We'll discuss it sometime. Yes, Adesh. Sure. This is the second point somebody had asked for. Take care, Ankita. Have a good day. Varsha. Yes. You can see it, Varsha. No, I won't say that. I don't have any regrets. Chandan. I don't play cricketer to play IPL and be famous. Cricket was something like enjoyable type of thing. I am going to support MI today. Right. So we'll end this here. I left it way back, man. Like 9th May, I guess 10th May, I left it. I wanted to pursue studies. It was not like I was forced to leave. I intentionally left. I have seen that, Rohan. I will reply. I will reply, Rohan. Don't worry. Okay? Chalo, let us end this on now. So study well, utilize your holiday, prepare well, and may God bless you all.